Pedro Montero nos va a hablar acerca del análisis de riesgo.
Regarding the first one, it is titled Risk Analysis and Environmental Information Management. He is a doctor in physics by University of Santiago. He's been working in the Institute of Intecmar in oceanographic modeling. Please correct me if I misspell the name of your unit. He is working in modeling tools for being used by the managers of coastal land. Yes, I come from Intecmar, and I will be talking on risk analysis and environmental information management, but regarding the contingency plans in Galicia. And we are not talking about any kind of contingency, but on the plan against pollution and oil spilling or other spillings. For example, the cases of Prestige, Casson, Urquiola, which were historical and huge accidents in Galicia, but also, for example, the kerosene spilling that was in Burgo in the north of Galicia this year, or another one produced in the area of Vigo recently. So, as a way of introduction, why are we here? Well, I will briefly explain to you how these plans are organized in Spain, and especially in Galicia. There are some port contingency plans, but when the crisis is bigger, then the regional contingency plan will be activated, and it is directed by the Xunta de Galicia, the regional government of Galicia. It is implemented by the Galician Coast Guards, and also Intecmar intervenes regarding collecting the collection of scientific evidences that could help to the solution of the crisis, and being prepared for giving an optimal response when the crisis arrives, and then doing a following up of the evolution of the crisis, of the spillings, and having a mapping of all the evolution. For example, if the crisis is bigger, then the Spanish national government will intervene, and especially Maritime Safety and Rescue Agency, which is SACEMAR. And then the national contingency plan will be activated. In Galicia, we are the only region in which we have Galician Coast Guard service. We have an agreement between the Galician Coast Guards and the Maritime Safety and Resource Agency at the Spanish national level, so to coordinate the intervention. But as I said before, it would be always the Spanish agency, the one which would be in charge if the crisis is a big one. So what do we do in SETMAR? We are working on the preparation of this response system, and this response system has been prepared through the collection of information through a system, a coastal inventory with database on the sensitiveness line index, and also there is a meteorological and oceanographic database. We also had, in the first project that we had a collection of the first data. We did some analysis of risk analysis, and also we created this atlas that you can see here on the left. And this Atlas contained some environmental information too. With this first project, Eurothips, and also ARCOPOL, with this second project, we updated the information. Also, we updated the risk analysis methodologies and the risk analysis that could be applied with these new methodologies, and also the visualization and dissemination of information, and that I will talk to you about now. With this project, ARCOPOL, our aim was to have a useful tool for designing future contingency plans. In this way, we could know where to put the facilities, how to face this crisis, and so on. So we studied the risks and also the vulnerabilities. Regarding risks, we collected an inventory of the stationary sources and also the mobile sources. And regarding vulnerability, we approached it from the socio-economical and also environmental approaches. Regarding the hazards calculation, we calculated the risks due to mobile focus. These mobile focus are normally maritime traffic. So first, we selected the year 2010 as an example. We collected the situation of all the boats going along our coasts. These were collected through AIS data. Then we created different scenarios. Our goal was to have a simulation of all these boats each 2 hours. We gave a probability of having an accident of each of the boats regarding the climate and meteorological conditions. And then also we had an hazard index. Then we had some modeling. We worked with 3 type substances, one that didn't decay, and then another one would have a high decay and a middle one too. We did the simulations for all year long. We could see the scope of these substances, and we created some hazard maps having several statistical variables classified by scenarios. As you can see, the percentile 95 of risk in the scenario number 1 with low decay, such as the case of the Prestige. Once we had this information, we also had the map of vulnerabilities. We divided the coast in cells of 1 kilometer length, and then we had the vulnerability and the risks selected, and with this matrix, with this risk matrix, we created different maps. We can see one of them here, and you can see the risk map for scenario number 1 for the depth coast of Galicia, from Rías Baixas to Artabro Gulf. You could see here also specific maps or risk maps for socio-economical vulnerability and also for environmental vulnerabilities. We also had information, as I said before, of the coastal environmental inventories. And so I will go directly to the second part. We are in a crisis, and what should we do then? Right. What to do in a critical moment? How to manage this information and how to share this information? Because the first question would be, why do we need to share this information? we are working with coast guards, so maybe it shouldn't be needed. Well, I will give you 2 examples to see that this is not the case. So this is really a challenge. When there is a crisis, there are different actors, different stakeholders. First, we would have the observers, people that are taking pictures from satellites or on the beaches. They go there and see where the oil are and oil spillings are. So we have the predictors, and then we have the end users, which are the most important ones because they are the real managers of the crisis, the ones that are going to make the mappings or to take the decisions. They can be the authorities, the press, and so on. There can be many different kinds of end users. So many times they need to share information. And this should be also very rapid because we are on a crisis. Then we also have another reason to justify the need of sharing this information. As I said, we have this agreement with the national government, and we give information to the regional coast guards. But if the crisis is a national one and we have very critical information and very precise information, it makes no sense not to share it in order to help to solve the crisis. So we also have a way to transfer this information to the Maritime Safety and Rescue Agency. So these are just 2 examples of situations where the information is needed to be shared. So, okay, we already know that we want to share, we need to share the information, we have the contacts, we all get on very well together, but how to share data? How? Everybody knows how to use the email and these tools. Well, we have some problems. As in the ANCORIM Project also was said, there are so many data, so many systems, so many sensors. We are talking about very different tools, very different models, and the agencies, which are the ones that are collecting this data. We have here INTECMAR, Meteo Galicia, SETMAR, AIMET, many agencies only in Galicia, and they have very heterogeneous formats. So this data can be in SIG or KML rasters, FGF, HF5, and then also the users can be very different ones, maybe scientists, but maybe also a panel that only needs some specific maps, or maybe somebody that needs information about the exact location of the spilling and which has a very low connection to internet. So we do know that the end users usually display geographic information, and they normally use, and this is very important, formal software data and procedures. So normally the users are people that have already worked on some kind of data and already know some procedures that influences our way to work with them. We cannot change the methods or the protocols without a real justification. So this transmission has to be also quick and robust. So our challenges are, first, that we need to access to remote data which are coming from different sources and in disparate formats. We need to transfer this data to diversity of users, and also through a diversity of tools. Let's imagine some people that excel SIG, but others just know Google Earth, and it is not the moment to learn how to use new formats. So we are talking about geographical information, and we need to create maps and to put information on them. First, we have the integration of 5 key components: hardware, software, but also data, people, and methods. So, as we are dealing with different agencies, what we need is to work with standardized international protocols. It's not the moment to invent new ways of communication and transfer. We're going to profit from what already exists. This is a real challenge, but we have here the superhero of the OGC. We can have part of this problem solved. Who is this superhero? Well, this OGC, it is the Open Geospatial Consortium. It is an institution of many institutions that work together in order to define protocols for supporting online interoperable solutions. They create standards in order to facilitate the transmission of information through the internet. They have some very famous ones, such as WMS, to render maps, also WFS in order to transfer geographical features, and WFST, which also allows to insert these geographical features in databases. With these tools, we've worked in the creation of systems that have different layers, so that in the down part of the tool we have different data from agencies of institutions. Then we have the top part of the part of clients. And by that we mean the different tools that are going to use this data. For example, SIG viewers, but can be also model creation tools, and so on. And then in the middle we will have these interfaces, these international protocols that allow us to collect information and to transfer them to the clients. This allows us to go from a tool that would have data in a particular computer and in particular format. It allows us to get these data, which are in the cloud, on the cloud, and this famous cloud from the internet, and with various web application or through Google Earth, we could collect these data and we could implement them for our particular purpose. We could use iTunes or Winamp in order to download a document or an archive. A file, sorry. In these projects of ARCOPOL and in other ones too, we've been working in the creation of this infrastructure, trying to promote the use of these kind of protocols by the institutions, and as a way of sample, we can see just a demo in the web page, which is just the top of the iceberg, because really there are many other ways of making use of this tool. The web tool from ARCOPOL, the demo one, it is just a web application. In this case, it is a viewer that have different layers which are put with a tool in different orders, and with Zoom you can select, for example, the area of Vigo, and you can select different layers of interest, for example, the index of coastal sensitiveness or the national parks. You can add different layers, such as, for example, shellfish gathering areas or modelings, nautical charts, and so on. We can also, with an example, we can also insert georeferenced images. And I think this is a good example for explaining, for example, I will tell you now, there was a project, a drifter project, and Florestina was launched to the sea. It was photographed by an helicopter, and then we could reference this spilling. You can see it in the Ria of Vigo. This image has the correct size and orientation, and thanks to this tool, which allows us not only to collect data but also to send geographical data. We can see, we could paint here with this pen, and with this tool we could introduce different layers with different data, such as, for example, the kind of substance, the quantity, and so on, and this will be a SIG object that could be inserted in our database through this WFST tool. This information could be in our server so that it could be used in a model that will allow us to do predictions and forecastings. So let's imagine that we are in a boat and we have internet connection, so we could identify this stain and we could collect information from this server. Other person could be doing some modeling, and the results could also be inserted in this database or in another database, and this could be mixed with other previous information. In this way, as a way of demonstration, we could see how many different information coming from various sources can be mutually and collectively seen in this same server. This information has a standardized protocol so that it can not only be seen in this tool, ad hoc tool, but also in other tools such as Google Earth, which is a free, quite known tool, or also in a SIG desktop, GIS desktop, such as Gaia, for example. Just finishing, this work has also been developed not only by Intecmar but also by many other agencies, and it was co-funded by different projects. We will be working on this in ARCOPOL Plus, which is a new project that has already been approved, and you can find more information in these websites. Thank you very much.